So now that you know a bit more about the active object pattern and its intent, applicability, structure, dynamics, and consequences and known uses, let's take a look at how you might implement this pattern, or how it is in fact implemented in the context of a real production system. And we're going to talk about how the active object pattern is implemented and applied in the context of Android and the Android Hammer framework, which stands for handlers, messages, and runnables. So let's talk through the steps to implement this pattern. The first thing you need to do is implement the invocation infrastructure, and that's done in Android through a couple of different means. The first thing is to implement the proxy, and you can see here that we're going to use the handler class. So we're going to point to the handler class as being the embodiment of this in the context of Android. And the handler class has a bunch of methods defined on it, which are send message delayed, send message at time, and so on. And these are all different concrete methods to make method invocations by the client. If you want to learn more about what a proxy is, take a look at the link below, which describes the proxy pattern that's given in the Gang of Four book. There's also a proxy pattern description in the POSA 1 book as well. If you want to see the source code for this, you can take a look at it. It's all available in the Android open source platform, AOSP. Then the next thing you do is you implement the method requests. There's various ways to do this. This particular approach in Android is a very simple approach that's kind of stripped down or slimmed down relative to what's possible with the full-blown POSA active object pattern. So this keeps it simple. It doesn't really have a proxy in the deepest sense of the word that takes arbitrary parameters and converts those parameters into messages. Instead, you just pass the message in. You create the message yourself, and then you send it via the send message call. So in this context, we're mapping Android messages and considering them to be method requests. The next thing you need to do is implement the activation list. In Android, that's very simple. That's done by the message queue class, which we've talked about before. And the message queue class is used to insert and remove method requests, which in this case are messages. And basically, it's implemented as a synchronized buffer that's shared between a client thread and other threads that run in the active object, which is where the scheduler and the servant reside and are used to actually carry out or execute the method requests or messages that are passed to it. So you can see here, this is just the Android message queue. You can go look at the message queue source code. It's part of the AOSP release. Next thing we need to do is we need to implement the scheduler. That's done in Android by something called the looper. And as you can see here, the looper has a message queue. So you can see that the looper is a class that contains a message queue as its implementation field. And it also has a method called loop. And what the loop method does, and we kind of talked about this earlier when we talked about command processor, the looper's loop method will block on the message queue waiting for the next message or method request to show up. And then after the next request shows up, it goes ahead and dispatches that particular message. And we'll see how that works in just a second. So that's what the scheduler part is in the context of the Android Hammer framework. Then the other thing we need to think about is how do you implement the servant? And this is done in Android with a method called handle message. And that's something that you get to write. So you have to write the implementation for this. So the way this works is the handler class defines an abstract method called handle message. And then if you want to implement a message handler, you have to extend handler, define your own message handler, which I called message handler, kind of a boring name. And then you figure out what it needs to do. So this is basically the servant. And so the servant's going to implement the methods. In this case, it's the handle message method. And it's going to be given a message. And you can see here what we do in this particular implementation, or the way that Android handles it in this particular implementation, is you can then basically take a look at the what field in the message that's passed, and you can control what those values are. So in this case, just for the example, we're going to have set progress bar visibility. That's one capability you can do in handle message. You can do a progress update. So these are just different things that you can use to update the state of the user interface in the user interface thread. And then there's also a way of being able to determine the rendezvous and return value policy. So in this particular case, what we're going to do is we're going to go ahead and basically get a message from the message we got. So we take the message we received. Remember, right now we're in the servant. We take the message we were sent, we extract the reply from it, and then we use that as what we call the reply handler. And then we can go ahead and create a response and send it back to the thread that called us. So this is how we can communicate back from the receiver back to the caller. So you can do basically two-way asynchronous calls, which is pretty cool. The rendezvous policy we're talking about here is used to allow clients to obtain return values from methods that are invoked on the active objects in the Hammer framework. So you can see we get a message, we set the return results, and then we say reply, send to target, and that passes it back to the caller. So a common idiom that you would typically use if you want to implement this pattern using two-way asynchronous calls in Android is to pass the original handler via a message to a background thread, which will then pass the response back to the original handler. So it's a pretty clever way of being able to communicate and get results from one thread back to another. So when we apply this thing in Android, if you take a look and see how this is actually used, there's a class in Android called Async Query Handler, which is a helper class that's used to invoke content resolver calls asynchronously so that the user interface thread is actually not going to be blocked. So the whole goal here is to not block the user interface thread. And the content resolver provides apps with access to the underlying content provider. Content provider is used in Android to give you access to CRUD data, which is basically create, read, update, and delete. CRUD is just a fancy name used for operations on data objects in Android. So you can do a query. The query will be run in the background and a result comes back. And in this particular case, the activity thread will be blocked until the query is done. We don't want to do synchronous communications, however, because that will end up blocking the user interface thread. So the alternative way to do this is to use the async query handler and provide asynchronous queries. And so what happens here is that the user interface thread will do a query on the async query handler, which will return right away, and the call will actually run asynchronously, so the user interface is not blocked. What happens under the hood is that goes ahead and will put the request onto a queue, a message queue like we've talked about, and this uses the handle message and send message methods. So the async query handler calls a send message call on a worker thread that will then implement the handle message servant. And then when it's done and it finishes running asynchronously in the background, then it'll return the result. Now, the cool part is that the worker thread can block, but having the worker thread block does not, in fact, block the user interface thread. So when it's all done, it returns, the call comes back asynchronously, and it sends the result back. And then the activity can pick up that result by its own handle message invocation, and it'll invoke a hook method called onQueryComplete. And that's how you get the result from an asynchronous query that an activity makes on the async query handler. This is a really cool example of how the active object pattern is actually used in Android itself in order to avoid blocking overhead for two-way asynchronous calls. Internally, if you take a look at the source code, which you can get at the link at the bottom of the page, the async query handler uses a subset of the active object pattern. And if you kind of poke around, you can see all the different pieces there. So it starts the query in the user interface thread that goes ahead and sends a message to a background worker thread. There's a looper running in that background worker thread that pulls the message off, dispatches it, and then the handle message method is invoked, and it does various things. And you can look at the source code for all the gory details, but it's really cool, and it's a great example of using the active object pattern in the context of asynchronous query handling in the context of Android. So to wrap up, the Android Hammer framework implements this nice subset of the active object pattern, very canonical subset. This is very common for people who don't need to go all the way with all the mechanisms that you would get with the full-blown active object pattern, just passing messages around in ways that allow two-way asynchronous communication. And it allows communication between a client and a handler that are running in separate threads of control. Now, if you really want to implement the whole shebang, you can extend Android with more sophisticated proxies and more sophisticated servants in order to create more canonical and complete active object implementations. And if you take a look at the link at the bottom of the slide, you can find out how you could do that. It's pretty cool. It's also worth noting, just because we've talked about this so much in this class, that the executor service framework that you get out of Java, that's part of the Java executor framework, can also be used to implement a nice subset of the active object pattern, which is very similar to what we talked about with the Hammer framework, just doesn't have quite as many Androidisms, or actually has no Androidisms in it. And so the ability to submit two-way asynchronous callables through the executor service framework is another nice example of this pattern being applied in practice. So that wraps up our coverage of the active object pattern. It's a very cool pattern. You should certainly be aware of it, and you should also be aware of the fact that languages like Scala and other languages have full-blown support for the actor model, which is just a more fancy academic framework or formalism for the active object pattern.